So now let's talk about surds. What are surds? So previously we saw examples of rational and irrational square roots. And so something like root 2, root 89, root 10, they're all irrational. And something like root 9, root 169, root 16, they're all rational because they're perfect squares. So the definition of what a surd is the square root of a number that is not a perfect square, and all surds are irrational, okay? So they are the numbers that result from taking the square root of a non-square number. I think this is a very nice way to think about it. So we have so many different examples. We have root 11, root 6, root 23, 3 root 2. That literally just means 3 times root 2. Remember, just like in algebra, when we have 3a means 3 times a, 3 root 2 literally just means 3 times root 2. Okay, so it's important to see that surds is actually very similar to algebra. And we'll see that when we get to addition and subtraction. 6 root 17 just means 6 times root 17. Now let's talk about 3 rules of surds. So the first rule I want you to understand is that the square root of xy is equal to the square root of x times the square root of y. We can read this both ways, right? So we can say that root 21 is equal to root 3 times root 7, but we can also write it as just root 3 times root 7 is equal to root 21. And I think the second way is a bit more intuitive for me. It literally just means if you're square rooting something times the square root of another thing, well, that's just equal to the square root of the two things multiplied together. Now, the same thing happens with division. So if I have the square root of, let's say 10 over the square root of 5, well, I can combine that under one big square root and just say it's equal to the square root of 10 over 5. And well, 10 divided by 5 is 2. So that's the square root of 2. So that's how division works. This is how multiplication works. So it's very similar to just normal algebra. The third rule, which we've already talked about, and you should already know, is that if x is positive, then the square of a square root is just going to be the number itself. So you can try this with any square root in your calculator. So if you put square root of, let's say, 15, and you square that, right? Basically what we're doing is square root of 15 times square root of 15. Well, this is equal to 15, okay? Now, what happens if x is negative? Well, the idea is that you can't actually take the square root of a negative number, right? Because think about it as if you put, let's say, square root of -3 in your calculator. If you put that, you're going to get math error. Now, why is that? It's because what is the square root saying? It's saying that a number times a number is equal to the thing inside. Now, if you have a number times a number equal to -3, well, that's simply not possible, right? Because we know that all numbers, when squared, will become positive. And so it's just important to understand that the square of a square root is the number itself, and these basic multiplication and division laws, which I think just work like normal algebra. So now let's talk about simplifying surds. Now, this is a really important concept, and it's one of the main things that carry over from year 9 all the way till year 12. So to simplify a surd or a multiple of a surd, we write it so that the number under the square root sign has no factors that are perfect squares other than 1. Now, that's a bit hard to digest, but I think instead of following all this, just think about it as if we have the square root of 12, I just want to think of 12, and I want to think of the biggest square number that is a factor of 12. Now, I always like to make a list of my square number factors. So obviously we have 1, but it's useless because 1 is just 12 times 1. Like there's no point there. The next one is going to be 2 squared, which is 4. Then we have 3 squared, which is 9. And I'll just go up to 16 as well, because we actually don't need this many for this particular question. So I look at 12 and I think, okay, which one of these is the biggest that is a factor that goes into 12? Now, I know that 4 is the biggest, right? 1 goes into it, but it's useless. 4 will go into 12. It's really nice. 9 doesn't go into 12, and 16, well, that's bigger than 12. So of course it doesn't go into 12. So 4 is our answer there. So we're going to say, using our previous law, right? Remember, root xy can be written as root x times root y. Well, we can say that root 12 is the same as root 3 times 4. And that can be written as root 3 times root 4. Now, why is that important? Well, we remember that the square root of 4 is just 2. So root 3 times 2. And that is equal to 2 root 3. Okay? So that is how we simplify a surd such as root 12. We just want to take out the biggest square number factor and then just work it out from there. So let's move on to 2 examples here, which I'd like you to have a go at. So just pause the video. And then after doing the examples, we'll go through the solution. And I want you to pay attention to the process because that's the most important part here. All right, so hopefully you've had a go at the 2 questions. So let's go through question 1 first. So we have root 18. Now I'm going to write down a list of my square numbers again. So I have 1, 4, 9, 16. So 5 squared would be 25. Then we have 36, 49. I think that should be enough for this. Yeah, I might as well go up to the next one as well, 64. Now, in terms of 18, which one of these would go into 18? Well, one does it. Well, one obviously does, but it's useless. So I might actually just not write this from now on. 4 doesn't actually go into 18. 9 does. So 9's a really good one. 16 doesn't, and then the rest of them are bigger than 18. So it looks like 9 is the one we're going to be using. So we're going to say that the square root of 18 is equal to the square root of 9 times 2. And then we can split that up, remember, using our surd laws. So it's going to be the square root of 9 times the square root of 2. And that is equal to, well, the square root of 9 is just 3. So we get 3 times root 2. And then we can just write that as 3 root 2. And that's just the way we write surds. It's just notation. So hopefully you understood how to do question 1 and you got it right. Now let's do question 2. So with question 2, we have square root of 108. Now I want to look through my square numbers and see which one of these goes into 108 quite nicely. So 4 does go into 108. I believe 108 is going to equal 4 times 27. Now, let's see if we can find any bigger ones, because that's the aim of the game. We want to find the biggest one possible. Now, 9. 9 also goes into 108. We know that 108 is equal to 9 times 12. So that also works. How about 16? Does 16 go into 108? Well, no. So 16 does not go into 108. Does 25 go into 108? No. But 36 does. So let's try 36. 108 is equal to 3 times 36. Okay? Now I'm going to show you the reason why we look for the biggest number. Okay? So I'm just going to do it 2 ways here. Let's say I didn't find the biggest one and I just went for the 9 times 12. Okay? So if I went for the 9 times 12, then I'm going to get the square root of 108 is equal to the square root of 9 times 12. And I can say that's equal to the square root of 9 times the square root of 12. And I can say that's equal to 3 times root 12. Now, the problem with this is 12 can be further simplified. In fact, from the previous slides, we know that square root of 12 is equal to 2 root 3. And so really our answer should be 3 times 2 root 3, which is equal to 6 root 3. So that is the problem. If we don't choose the biggest one, we're going to have to simplify again. Whereas if we chose our biggest square number that went into 108, which was this option here, let's see what we get. So root 108 is equal to root 36 times 3, which is equal to root 36 times root 3. And that is equal to 6 times root 3. And we know that we can just say that is equal to 6 root 3. So we get the same answer, we get it quicker, and we don't have to simplify again. And that is why we always want to go for the biggest square number when we're trying to simplify a surd. Okay, so how about instead of simplifying, we're actually going to be expanding a surd out, or we're going the other way. So how would we express these simplified surds as the surds of a whole number? Well, remember how we were doing the root 108 and we split it up into root 36 times root 3, and then we got 6 times root 3. Here, it's very much a similar process, except the 3, we actually have to turn back into its square root. So the 3 is equal to the square root of 9. And so we have square root of 9 times the square root of 7, and that is equal to the square root of 63. Okay, so with these kind of questions, all we're going to be doing is changing the coefficient in front of the surd, so the number, the integer, into its surd form. So maybe pause the video and have a go at question 2 on your own, and then I'll go through it. Okay, so with question 2, it's very similar to question 1. I just need to change this 9 into a surd. And I know that 9 is equal to the square root of 81, and that times root 3. So square root of 81 times square root of 3 is equal to square root of 243. And that's just using our surd laws. So you can see 9 root 3 is equal to root 243, and 3 root 7 is equal to the root of 63. So hopefully you understood that. By now you should be familiar with the 3 surd laws and how to use them. In our next video, we'll be looking at more examples, a few harder examples in terms of how to use these surd laws. So catch you there.